Okay, so this is the problem we had in class 2x squared plus 4x plus 1. Now what makes this different equals 0? What makes this... So this is the problem we had in class 2x squared plus 4x plus 1 equals 0. And we're going to use completing the square to solve for x, to find solutions for x. But what makes this problem different from the other problems we tackled is that there's a coefficient of x squared that's not 1. So instead of there being nothing there, there's a coefficient of 2. Okay, so what do? Well, first of all, we're just going to consider these two terms, but what we'll do is we'll factorise out the coefficient of x squared. So the next line is going to be 2 outside of x squared plus 2x plus 1 equals 0. So basically I divided this coefficient, the coefficient of the x term, by 2, the coefficient of the x squared term. And you can sort of see if I go backwards from here to here, 2 times x squared is 2x squared, 2 times 2x is 4x. So they are equivalent lines, these two. Okay, so what this does is it gives us this format here, which we are familiar with, we can do something with. So I'll leave that as 2 outside of, and we'll apply the usual techniques of completing the square, x plus, and then divide the x term's coefficient by 2, and square the whole lot. Now I guess this is the next bit which becomes tricky in that we've got the term that we're going to subtract the square of, but because we've multiplied the whole thing by 2, we're going to have to multiply it again by 2 over here. So I'm subtracting 2 times 2 over 2 squared. So the 2 times comes from here, and the 2 over 2 comes from here squared. So I guess the idea is that if you expanded this, it's this squared term is the thing that we've artificially added to complete the square. And then if I multiplied it by 2, the term that we've artificially added will be this squared times 2, which is why we then take it away to keep it even, or to keep it equal. Then I'll put my plus 1 in, and then equals 0. Okay, so that's basically the completing the square step. We just got to simplify that. So the first part stays the same, 2 outside of x plus, and we know 2 on 2 is 1. So x plus 1 all squared minus, okay, well, we can probably just do this in one step. 2 on 2 equals 1. 1 squared is 1. 1 times 2 is 2. Plus 1 equals 0. So we have 2 outside of x plus 1 all squared minus 1 is equal to 0. And that is now in the completing the squares type format. So you could talk about, if this is instead of being equal to 0, if we said instead this is equal to f of x, so it was like a function, we would say this is in turning point form. Alright, but let's solve it anyway. It's equal to 0, so let's solve it. So first of all, we'll add 1 to both sides. I'll do it in blue so you can sort of see these are the balancing operations. That leaves me with 2 outside of x plus 1 all squared equals 1. Then I'll divide out by 2, and that gives me x plus 1 all squared is equal to a half. And then we'll take the square root of both sides. When I square root something with a variable in it, I don't need to do pluses or minuses, but when I square root a half, I have to remember that the result is plus or minus the square root of a half. So I'm going to move to the next slide, and then you'll be able to see that, the result of that. So the square root of x plus 1 all squared is just x plus 1, and then the square root of a half is plus or minus root a half. So I'll just do that now. So we have x plus 1 is equal to plus or minus the square root of a half, like so. And then all we have to do then is take 1 away from both sides. And it's usual to put the plus or minus in the middle. You don't have to, but so that leaves me with x here and negative 1 plus or minus the square root of a half, like so. So the solutions, that's all you have to write. That's it. That's the solution. But you've got to remember that that is actually two solutions. If I did spell it out, I would say x equals -1 plus the square root of a half, or x is equal to -1 minus the square root of a half. Okay, so that's basically it. If you can do all of that, then you're doing a good job. Now, on a different screen, I'm just going to tell you how you could simplify that a little bit further. You don't really have to do this next step at all, but if you like things being nice and tidy, this is what you would do. Let's start off with x plus 1 equaling the square root of a half. Well, we could simplify that a bit by saying that's the square root of 1 over the square root of 2, which equals 1 on root 2. Then, if I rationalise the denominator, I would get root 2 on 2, like so. So I would have x plus 1 equaling root 2 on 2, and therefore I should have plus or minuses there, of course, just x is equal to -1 plus or minus root 2 on 2, which is equal to -2 plus or minus root 2 all on 2. As I said, it's not essential to do that, but that gives us a rational denominator, which is sometimes a little bit handy to express your solutions that way, but not necessary. Okay, that's it for me. Thanks.